This is the isosceles triangle problem from our homework, from our maximum and minimum problems. I started off with a circle and the isosceles triangle drawn inside the circle. And now I just want to add the information about the circle to our diagram. It's very similar to what we did with the cone earlier on. We are going to draw from the center of the circle to the top of the triangle, 4, from the center of the circle to the edge of the triangle, 4 as well. And to find the area of a triangle, I need the base times height divided by 2. So I'm just going to add in some more information. And again, we want to make that a right angle. So this is a value of x. So the height of the triangle would be 4 plus x. And then what we need to have is a way to relate the base and the height together. So let's just call the bottom side of our two triangles, let's call them y. So the base of our triangle is going to be 2y, and the height of our triangle is going to be x plus 4. And let's put those things into our formula. So our base times height is 2y times x plus 4, all divided by 2. Let's just do some cleaning up here with the algebra. The 2's can cancel out. So our area is going to be the y value times x plus 4. Like I said at the start, this is kind of like the cone inside the cylinder question. We have a relationship inside the triangle that is Pythagoras. We have x squared plus y squared equals 4 squared. So our y value, our y squared is 16 minus x squared. So our y, we don't have to worry about negative square roots. Talking about length is 16 minus x squared. And we're actually not going to use a square root. We put it in the formula. We're going to use the exponent of a half so we can use our derivative rules. So our function that we want to maximize or minimize is our y value, 16 minus x squared to the half times by x plus 4. So we don't have an option now. Like the last examples we've been working on, we said we could sometimes multiply through, sometimes we can't. Here we can't. Here this has to be the product rule with the chain rule involved. So I'm going to kind of go through the derivatives of 16 minus x squared to the half and work that out as the f, and then for the g, it's x plus 4, and find those derivatives for f prime and g prime. So I went through the process of the chain rule for 16 minus x squared to the half. The half comes down in front of 16 minus x squared, and that exponent of 1/2 then decreases by a degree, so it becomes negative a half, and then times by the derivative of my base function, so times by the derivative of 16 minus x squared. So I'm showing my chain rule. What I want to do is I want to simplify, so the half and the negative 2x go together. So my derivative for the 16 minus x squared to the positive half is negative of x, 16 minus x squared, all to the negative half. So that's f prime. Haven't done a chain rule like that for a while, so it's nice to review that. And then the derivative of x plus 4 is just 1. So we want to put those two thoughts together now into the product rule. And again, if we haven't seen the product rule for a while, it's not a terrible thing to have to write it out. But we're going to go f prime g plus f g prime. This is our derivative that we want to be able to work with. So let's plug those things in, and then let's do some simplifying. If we substitute, we get f prime, negative x times 16 minus x squared, negative half, times g, which is x plus 4. Add that to 16 minus x squared to the half times by 1. We are going to simplify this and make it equal 0. So we start looking at things again. This is where our common factoring skills come in. We want to take the 16 minus x squared to the negative 1/2 out of the expression. It's in both terms, 16 minus x squared. Again, you take out the smallest number. So we have a negative x left over with x plus 4. And then if you factor the negative 1/2 out from the positive 1/2, we are left with 16 minus x squared to the 1. And that's still times by 1. So let's simplify this a little bit more, and then we're going to solve it. I moved my negative exponent to the denominator. 16 minus x squared to the positive half is now in the denominator, and I have a numerator. Again, I'm not concerned about where my function is undefined. So really, if I was to cross multiply and start solving now, the 16 minus x squared to the half just disappears with cross multiplying. So my equation is really about the top of my function, negative 2x squared plus 4x plus 16. We can factor out the negative 2. Again, the negative 2 doesn't have any bearing on the answer because it's a constant. So all I really want to do is factor the x squared minus 2x. So it's x minus 4 and x plus 2. Well, as you can see, I made a mistake. I'm going to go back and I'm going to just erase here for a quick second. Some of you may have caught this earlier on. When I multiply through by negative x, this has to be a minus 4x up here. And I recognize I was going to have a mistake because I was going to end up having the wrong signs on my factors. So this would be a minus sign. When I factor out now, this is plus 2x. And I want this to be x plus 4 and x minus 2. I needed my x to equal negative 4 to give me my minimum number, which again would be a height of 0 for my triangle, and then x to equal 2 to give me the actual answer for the maximum. If you go back to the start of the question again, we talked about what is the height of the triangle, and it's x plus 4, so the height of the triangle is going to be 6. The radius, not the radius, how about the base? The base of my triangle is 2y. So I need to figure out what my y value is, and my y value was the square root of 16 minus x squared. So my y value, if I simplify this, y equals the square root of 12. That's like 4 times 3. So y equals 2 square root of 3. That's the 1y value. So if I put all those thoughts together, then my base is going to be 2 of those. So it's 4 root 3. And I think that's where we get to stop. I don't think we have to find the area, but if you wanted to find the area, of course you could. Height is 6 centimeters and the base is 4 root 3.